Okay, in this problem we want to know which of the following pairs of numbers is a solution to the equation 3x squared minus 54 equals negative 21x. We've got the choices negative 6 and 3, negative 2 and 9, negative 3 and 6, negative 9 and 2. So again, this would be a problem you could certainly brute force check. You know, I could substitute in negative 6 and square it and multiply by 3 and then subtract 54. I would get some number. I could take negative 21, again multiply it by negative 6, and see if they're equal or not. I could do the same thing with positive 3. Put 3 in, square it, multiply by 3, etc. So you can brute force check these, okay? Again, that's the good thing about having answer choices, so don't forget to do that on a test if you get stuck. You can always grind through them. Again, be careful because it takes a lot of time, so make sure you have time to do that. But when all else fails, that will be a way to help figure them out. But again, let's talk about the algebra way. So 3x squared minus 54 equals negative 21x. What type of equation is that? That's, you know, the thing I pick out and recognize, because then I say, oh, there's a procedure for those. And the thing to notice is I've got this power of 2 on one of my variables, and then I've just got an x floating around and some numbers. That makes it quadratic. And to solve quadratics, my first attempt is to usually try to factor it. Okay. Maybe you've also seen the quadratic formula. If you remember that, you could certainly use it, but a lot of people forget that formula. Okay, so to solve a quadratic equation, the first thing we want to do is make one side of the equation, make one side 0. So this is your recipe again. It's like you're making a cake. So whenever I see my x squared, I want the number in front of that to be positive, and it already is. So for me, I'm going to move everything over to the left side. So to get started, I'm going to add 21x to both sides. Okay, well, I would have 3x squared minus 54 plus 21x. None of those are like terms, so I can't combine those. So I'm just going to write them all down. I like the x when we factor, you always see the x term, the term involving x in the middle, so that's where I'm going to put the positive 21x equals 0. Okay, so the next thing I ask myself is, can I simplify this equation? And by simplify, what I mean is, can you make the numbers smaller? And to make the numbers smaller, if you make the numbers smaller, it'll make factoring easier. You can't always do this step, but it's a good thing to ask yourself. Well, I think, okay, let's look at the coefficient on x squared. That's a 3. 21, is that divisible by 3? Yeah, it actually is. 54, is that divisible by 3? Well, you could check on your calculator, 54 divided by 3, and you'll see that it is. So what I'm going to do is, I'm going to divide the left side by 3. And when I divide the left side by 3, every term gets divided by 3. I also have to divide the right side by 3, but it's already equal to 0. So 0 divided by 3 is still going to be equal to 0. Okay, so 3 over 3, that's just going to leave me with x squared. Positive 21 divided by positive 3, that's positive 7x. A negative over a positive, that's a negative. 54 divided by 3. Again, you could break out your calculator. That's going to be 18. So 54 divided by 3 is 18. So now I think, okay, here comes the factorization part. I'm left with a positive 1x squared. So I'm going to make two sets of parentheses. We put an x in the front parts. And now I ask myself, I need two numbers that satisfy some criteria. Two numbers that satisfy, well, they have to multiply. They have to multiply to the constant, which is negative 18. So I know that I'm going to need a negative number, and I know I'm going to need a positive number to get a negative when I multiply. And they have to add up to positive 7. Okay, so I think, let's see, what multiplies, I forget about the negative for a second. I think about what multiplies to 18? Well, there's 1 in 18. I don't really see how I could make one of those positive and one negative and get a 7 out of it. There's 2 and 9. 2 and 9. I think we could make one of those positive and one negative and get a positive 7. There's also 3 and 6. Again, I don't see how I could make one positive and one negative to get a 7. So it looks like to me that 2 and 9 are my candidates. Well, one has to be positive, one has to be negative. I want them to add to positive 7, so I think we should make 9 the positive one and 2 the negative one. So again, negative 2 multiplied by positive 9, that's negative 18. If you add them up, you do get positive 7. And now you just drop each one of these numbers into your parentheses. So we've got x minus 2 and x plus 9. I could have had x plus 9 and x minus 2. It doesn't matter the order that you do that. At this point, once we have it factored, we just take each expression in our parentheses and we set it equal to 0, and then we solve those more basic equations. So x minus 2 equals 0. I could add 2 to both sides and get x equals positive 2 as one of my solutions. And then x plus 9 equals 0. I would subtract 9 from both sides. 0 minus 9, that's going to give me negative 9. And now I've got my two solutions, 2 and negative 9. So they've got it written as negative 9 and positive 2. Same two numbers, so that would be your solution.